All right. Principal values for sine, cosine, and tangent. Remember, they come from looking at the graphs of each of the inverse functions flipped over the y equals x line. Sine was negative pi halves to pi halves. So I always think of it as just kind of that chunk right there, the first and the fourth quadrant. Cosine is really easy because it follows along where cosine is always positive up on the top. And then tangent matches sine. These are the pictures that I will show you over and over and over again to remember the principal values for sine, cosine, and tangent. What we have and what this gives us is different domain values. We actually know a lot of different domains about sine, cosine, and tangent, and you don't even realize it. If I said, give me all real answers, that's when you add plus or minus 2 pi n, or in some cases, pi n. Bounded depends on what I tell you. If I said, oh, give it to me between 0 and 360, or 0 and 2 pi, or between 0 and 180, that depends on my instructions. But we already do a lot of that. And then the principal values are the most simplistic answers. The ones that give us a function with our inverse functions. And if your calculator is to give you an answer, it's always going to be one of those principled values. We always talked about how there's two answers, but your calculator is only smart enough to give you one of them, and that is the principal value. All right, let's take a look when we might use these different domains. So if I wanted to solve inverse sine of 1/2, let's say that I first wanted to start with all real numbers. Well, I would think about where sine is positive 1/2 to begin with, and that is here and there. So if I'm talking about all real numbers, that's going to be pi sixths, and then I want to keep rotating around and around and around. So I'll add on plus or minus 2 pi n. My favorite, or one of my favorite spots, not as favorite as 11 pi sixths, is right here at 5 pi sixths. That's another place that we're going to have sine be positive 1/2. And again, I want to take that and rotate around and around and around, so I need to add on plus or minus 2 pi n. That will let me go through and have all of the possible places where that's going to hit in all real numbers. Now let's talk about a bounded situation. What if I just told you, okay, give me all the answers in between 0 and 2 pi? Well, that's going to basically be the same answers, just not rotated 2 pi n. Just going around one time at pi sixths and 5 pi sixths. Lastly, what if I said, all right, now tell me the actual answer in the principal values? I really wish I could write on this a little bit better. All right, the principal values, that's just for sine right here in the first and fourth quadrant. We know this only happens one time there, and that's going to be pi sixths. If we were to plug in the inverse sine of 1/2 into our calculator, it would give us 30 degrees, or if we were in radians, pi sixths. It is the most simplistic answer. Each one of these is important in its own right, and it depends on the situation which one you will need to use. Most of the time I will tell you, give me it in real, give me a bounded, and I'll tell you the bounded, or give me the principal values. But you really do need to be smarter than the problem and smarter than your calculator to be able to figure out which one is appropriate. Yay, trig!